Welcome to The Explainer. Today, we're tearing into something seriously fascinating. It's a document that's 188 pages long, incredibly detailed, and quite frankly, it's the ultimate survival guide for military cargo. We're talking about MIL Standard 2073-1E, the Department of Defense Standard Practice for Military Packaging. You know, if you've ever wondered exactly how the military ensures a super delicate piece of electronics or even a massive mechanical part actually survives being shipped to the absolute most unforgiving environments on Earth, well, this standard holds all the secrets. To really understand why this standard exists in the first place, we have to look at the Defense Transportation System. It's defined as the worldwide transportation infrastructure that supports Department of Defense transportation needs in peace and war. We have to remember that military logistics isn't just, a friendly porch drop-off by your local delivery driver. It's literally about global power projection. We're talking about moving vital, highly sensitive assets through the absolute most hostile, chaotic environments imaginable and ensuring they work flawlessly the very second they're unboxed. Stamped with the official seal of the Department of Defense, this standard carries ultimate authority. And it makes sense, right? The military requires a staggering level of exact, unwavering precision just to solve the sheer chaos of war. Think about it. When a combat unit is deployed, a delayed or damaged part isn't just a minor inconvenience. It's a mission failure. This standard is the rulebook designed specifically to prevent that failure. Okay, let's dive into this. We're going to walk through the complete escalation of defenses today. First up, extreme military logistics. Second, fragility and ground rules. Third, the 5 methods of preservation. Fourth, calculating perfect protection. And finally, levels of packing. All right, Section 1, Extreme Military Logistics. The rules in this manual definitely don't apply to a quick drive across town. These standards are built from the ground up for worst-case scenario logistics. We're talking about wartime deployments to operational units where basic infrastructure might not even exist. We're looking at depot-level repairables, reusable specialized containers, and, get this, items intended for delivery at sea. Just imagine having to package a highly sensitive component so perfectly that it can literally be dropped directly into the ocean and recovered later without a single drop of water getting inside. That's the baseline we're working from here. Moving on to Section 2, Fragility and Ground Rules. So before anything gets packed, the standard divides items into specific groups. On one hand, you've got your common group items. These are things weighing under 10 pounds with no dimension greater than 24 inches, and they have a fragility rating of 85 Gs or more. For these, the military just uses predetermined packaging codes. But on the other hand, we have special group items. These are items with peculiar weights, really strange sizes, extreme complexity, or just extreme fragility. You can't just box these up using a standard code. They require intense, specialized engineering, custom drawings, and highly specialized containers. Now here's a crucial point. The military absolutely does not mess around with standard commercial filler. Loose fill materials are completely prohibited in all military packages, with only a few super rare exceptions for absorbing specific hazardous liquids. So if you are expecting a military crate to be full of packing peanuts, think again. The military's logic here is hyper-specific and incredibly rigid. Loose fill settles, it shifts around, and it ultimately leaves items vulnerable to impact. It simply doesn't cut it. Instead of just throwing in some bubble wrap and crossing their fingers, the military relies on hard, exact data. They calculate what's called a fragility factor. This is defined as the maximum force, measured in Gs, that can be applied to an item in its non-operating state without causing any physical or operational damage. To put that into perspective, dropping a standard smartphone on a hard floor generates roughly 40 to 60 Gs of force. The military literally measures the exact G-force an item can withstand by simulating drops, transport shock, and sudden stops, all to precisely engineer the exact amount of shock absorption required. It turns packaging into a hard science. Section 3, the 5 methods of preservation. Let's see how this builds, kind of like an escalating tier system of armor. Method 10 is your basic baseline, physical protection. This just keeps the item safe from mechanical damage using blocking and cushioning. Method 20 adds a preservative coating, think heavy grease or volatile corrosion inhibitors, to stop rust and chemical breakdown. Method 30 steps it up to waterproof protection, literally sealing the item in a heat-sealed bag. Method 40 goes even further to water vapor-proof protection, making sure not even the ambient humidity in the air can penetrate. And then, right at the very top, we have the ultimate defense, Method 50. Now, what's really interesting about this is the extreme lengths they go to from Method 50 package. This isn't just about keeping water out anymore. It's about actively destroying any moisture that might already be inside or trying to sneak its way in. Method 50 requires a heat-sealed water vapor-proof enclosure, sure, but it also mandates the inclusion of activated desiccant to absorb moisture, alongside a visible humidity indicator card to constantly monitor that internal environment. They're essentially creating a perfect self-sustaining microclimate.
The rules for maintaining a Method 50 environment are just incredibly strict. You can't just toss a little packet of silica gel into the box and call it a day. The desiccant actually has to be activated and bagged to meet a specific military standard, MIL D 3464. It has to be strategically placed in the voids of the package so it absolutely never bears any physical load. You've got to have those color change humidity indicator cards visible through a window or immediately within the closure. And crucially, under no circumstances can the desiccant come into direct contact with the critical surfaces of the item. They are literally that paranoid about chemical contamination.
Section 4. Calculating perfect protection.
The sheer scientific rigor here is absolutely incredible. The DoD doesn't just guess how much desiccant to use. They calculate it using exact mathematical formulas. Formula I is used for flexible bags, calculating desiccant based on the area of the barrier material, plus variables for the exact weight and type of dunnage inside. Because believe it or not, things like wood or bound fibers actually hold their own moisture. Then you have Formula I, which is used for rigid metal containers, calculating based on the internal volume. They factor in absolutely everything, right down to the cellular makeup of the cushioning material. And this brilliantly illustrates how all these rules come together. It's essentially the literal brain of the standard, the Military Packaging Requirements Development Decision Chart. It forces the planner through an entire gauntlet of questions. Is the item hazardous? Is it consumable? What is its fragility factor? Is a specialized container required? By following this massive flowchart, the complex logic of the military supply chain ensures that every single item gets exactly the customized level of protection it requires to survive its journey. Finally, Section 5, Levels of Packing. So the DoD classifies the actual exterior packing into distinct levels. Level A packing gives you maximum worldwide protection. This is for gear that might be subjected to direct exposure to extreme climates, dropped in the mud, stored in the open during a massive mobilization, or even kept in war reserves for years on end. It has to survive literally anything. Level B packing is a step down from that. It's moderate protection. It's used when the military knows the item won't be directly exposed to the harshest elements, like during standard containerized overseas shipments or secure foreign military sales. In physical reality, to survive that kind of open storage and extreme weather under Level A, you're looking at heavy-duty overseas-type wood boxes or highly engineered plastic and metal reusable containers designed to last for 100 trips or more. For Level B, since the journey is a bit more controlled, they utilize domestic wood crates, weather-resistant fiberboard containers, or multi-application fast packs. It is the absolute ultimate final layer of physical defense before an item is deployed. We've really seen how the military transforms an ordinary box into a highly engineered, shock-absorbing, climate-controlled survival pod. The sheer amount of thought, mathematics, and strict regulation that goes into just the packaging alone is absolutely staggering. Which leaves us with this final thought for today. When you think about your next fragile package arriving broken in the mail, ask yourself, could commercial shipping learn a thing or two from the rigorous, uncompromising precision of the defense transportation system? Thanks so much for joining me for this explainer, and keep questioning how the world works.